I leave the word to Pat for the next 15 minutes.
Thank you very much. I would like to try to summarize the theory building attempts I have found in software engineering. It doesn't mean I cannot guarantee it's complete, and it's also matters of definition. But I found a few sources which I would like to report here. What's written in the short paper is actually based on our recently updated book on experimentation in software engineering. We published that the first time in 2000, and there is a new edition that came out this year. And while advertising, I would like to bring your eyes to our book on case study methodology in software engineering, published this year at YD3. So I'm approaching this from the empirical studies point of view and see how could we synthesize and build knowledge and subsequent empirical studies on theories in software engineering. So that's my point of view in this. We will have already seen definitions of theories. This is taken from one of my sources, Johanna is writing on that the theory provides explanations and understandings in terms of basic concepts and underlying mechanisms which constitute an important counterpart to knowledge of passing trends in their manifestations. I don't want us to discuss this right now, but just setting the scene. This definition is taken from the systematic literature review of experiments from in software engineering from 93 to 2002. So here is a decade missing. I haven't seen anybody making attempts to cover the next decade. So that's something we should do, of course. But this is actually, nevertheless, this is an area where experimentation in software engineering actually started growing. So we could at least see some starts of where, or we could expect some theory discussions being here. However, and there are 40 theories identified or written about in these 113 experiments, but only 23 of these 113 actually talked about theories.
Be careful.
So,
113
yes.
has nothing to do with articles. An article can mention one or more.
Yes,
experiments.
yes. I don't really remember whether these 113 were articles or experiments, but we can see.
It doesn't matter.
Right. There were 103 articles which published 113 experiments. So compare the 23 to the 103. That's the same magnitude of order. Anyhow, the key problem is that they conclude that only 2 of these theories were used in more than one article. So the purpose of using theories for communication, for building upon existing knowledge was totally ignored. That was the results from, and again, this is a little bit old, but I'm afraid the situation is not much better today. There are 2 other attempts to define software engineering theories. Endres and Romba published their book on empirical observations, laws, and theories. They identified, I don't know how, 50 laws, which they call kind of a repeatable phenomenon in a natural sciences context. So they take that view, even though I would argue that comparing software engineering to natural sciences is not, it doesn't work really. Another problem with these laws is that very many of them are on general management. And I think we have to relate to those. But it's very strange to define a general management theory as a software engineering theory. There are general management theories that applies to software engineering, but I think we have to discuss this, how this relates and what would this do not relate. Then they have notions of hypotheses, which are proposing tentative explanations for a phenomenon, and conjectures, which are guesses about the phenomenon, which they then set out to test. So they also then report 25 hypotheses and 12 conjectures. It's pretty ambitious as a book. It hasn't set too much of a mark in the software engineering field, and I think it lacks the empirical basis for why should these be theories. Another attempt by Andreas Endler was his paper in 2001. I think it says 2001, yes. On a preliminary software engineering theory. So perhaps this preliminary is to set there to not be too brave and ambitious. And he defines 3 fundamental hypotheses, 6 central hypotheses, and 4 elementary hypotheses, and kind of defines a hierarchical relation between these, trying to build up kind of a system of hypotheses, which then he calls his preliminary theory. I think here the problem is that it is not precise. An example theory I write here: object-oriented programming techniques have advantages against structured programming techniques. Yes, okay. I could turn the other way around and say, yes, that's true too. So, unless you mean which you talk about which advantages, to what extent, or what aspects of this, it's useless. So that's the work I've seen. If you have seen more collections of theory, I'm happy to see what you have found. We'll take that later. So, given this, and when I started thinking about this, what types of theory do exist? And there is a taxonomy by Gregor, which in this systematic literature review was adapted slightly to software engineering by Hanai. They distinguish between analysis theories, explanation theories, prediction theories, combining those two into one, and finally design and action theories, which they question whether that this is a theory or not. So, but if taking those 3 distinct different ones, analysis theories include taxonomies, classifications of ontologies used to analyze. So they basically do not state anything about how things relate to each other, only that this is a kind of a structure. Carl von Linnaeus' scheme to classify flowers and so on, that's kind of an analysis theory. Explanation theories to explain, for example, why things happen, contributing factors, but only on the explanation side. The third class of theories actually have the ambitions of predicting. So while these kind of theories explain from a certain situation, this is why it happened, it does not say that this is a general pattern. However, when we talk about prediction theories, they say do some kind of a forecast of what will happen. So I think these different types also important to have in mind when we talk about theory. Which type of theories do we do we talk? Then I would like to go into more what's written on theories in software engineering. In this book by Schulzinger and Föberg, there is a chapter on software engineering theories. It's entitled Building Theories in Software Engineering. And they propose that theories are expressed in these types of, in this framework. They have constructs, which entities the theory are expressed in, proposition about the relationship between the constructs, explanations about these relations on the constructs, and scope, which is the scope, the limits for this theory, or where this theory is assumed to be applicable. And I think here this may be the connection to the SEMA kernel work, which is also a kind of a framework where you can relate propositions and explanations to. They have another type of proposed framework that you express actor, technology, activity, and type of system you work on. And I think what I try to capture is that what I also addressed in the discussion before about the generality, universality, that it's different between software and software. So, for example, software system is important whether you develop an embedded safety critical system compared to developing an app for your cell phone. That's two different kinds of software. So, finally, what characteristics should we set on a theory? It should be empirically founded. That must be empirical evidence. It should have a defined scope, and it should be relevant and useful. So that's, to me, the key criteria for a theory, whether it is software engineering or not, but now we're talking about software engineering. And I think we have to have all these in place. Okay.
Thank you.